Okay, now the next question that's posed is we have this rectangle. It looks like a blob up here, but it's a rectangle. Delta x by delta y containing this point. Now if we approximate the area above this rectangle within the sphere, so we got this column that goes up to the top of the sphere. If we estimate the volume of that column or that prism by using the distance from the point x star y star up to the sphere, well, if delta x and delta y are small enough, we get a very good approximation to the complete area. You know, our approximation is going to depend on where we locate x star y star within the rectangle, and locating it at the middle of the rectangle doesn't give us a completely accurate answer, although it's probably the best choice if we want to have the best chance of being close. But this could be anywhere, and the point again is if delta x and delta y are small enough, there's not going to be much difference. Okay, there's not going to be much difference to the value, the Z max that we get from this point and the Z max we would get from any other point. So there's not much difference between this and the average altitude from points of this rectangle up to the surface of the sphere. Okay, so we're going to use this approximation, and this is going to be a sufficient approximation when we start putting things together into integrals to give us an integral that will give us the accurate expression for the surface area, for the volume of the sphere. And it's actually very straightforward. There's some details, trigonometric substitutions and stuff, but it really isn't bad. You'll see it soon, like probably in the next class. Okay, so our approximating rectangular solid is going to look like this. It's going to be delta y by delta x by the square root of 16 minus x star squared minus y star squared. And its volume is going to be this. Okay, it's going to be the square root of 16 minus x star squared minus y star squared. How far we got to go, how high that column is, multiplied by the area of the base, which is delta y times delta x. And of course we could reverse the order of delta y and delta x if it's convenient to do so, and often it will be. And we call that a delta V. That's our contribution to the total volume between the xy plane and the sphere. Okay? Very important quantity, and it's really important that you understand this very well.